Hi everyone, it's Math with AUB, another simple question in mathematics, but it has been blended in the field of terminology of discrete mathematics or discrete structure, or you can say algebraic structure. Method of proof is contrapositive. If a square is even, then a is even, where a is an integer, no doubt a is an integer. From discrete mathematics, we are familiar that P implies Q. Its contrapositive is given by negation of Q implies negation of P. This is implication, simple implication. Then this is contrapositive of this implication. Contrapositive. Very cool, very simple idea is that implication. If P then Q, if P then Q, we are to use this method contrapositive. Now let's write this statement in contrapositive wise. If P then Q, A square is even, then A is even. We have to prove it using contrapositive. Means this is our P implies this is our Q. We have to take negation of this one. A is not even integer, then A square is also not an even integer. Not an even integer. Simple, we have used the terminology of contrapositive. We have written its converse as well as negative. Contrapositive, or one can write this one in more technical sense. If A is odd, not even means odd, where A is an integer. If A is odd, so does A square, means A square is also odd. It is the way of discrete mathematics to write A is not an even integer, then A square is also not an even integer, or it is given to us A is integer, we can, it is very safe to write if A is odd, so does A square, so does A square. We have to prove this. If A is odd, then we have to prove A square is also odd, or one can take A is not even, then we have to prove that A square is also not an even integer. Not even means odd, not means odd. A is odd, A is odd, then any odd number can be written as, that is the mystery of number theory. A can be written as 2 times any number plus 1, or A can be written as 2 times any integer negative 1, where M belongs to Z set of integers. Whatever the value of M from integers, or integers runs as 0, plus minus 1, plus minus 2, plus minus 3. 3 dots shows the continuity, the standard one. 2m plus 1. Plug in any value, even 0. 2 times 0 plus 1, 1 is odd. 2 times 0 minus 1, minus 1 is 1, minus 1 is also odd. Taking what? 2 here, 2 to the 4, 4 plus 1, 5 odd. 3, 2 3 the 6, 6 plus 1, 7, it's odd. 2 3 the 6, 6 minus 1, odd. They always gives us odd. That is the general form to write an odd integer. That is the general form to write an odd integer. Odd integer, odd integer. Odd. Okay, taking this, we have to prove that its square is also even. Squaring both sides. A square is 2m plus 1 whole square. That's our A square. Open this up. You are familiar from little bit mathematics, little bit algebra. A square, square of first twice, first into second plus the square of second. We have here 2m 1, 2m times 1. It will become 4m square plus 4m plus 1. Taking 4 common from here, m square plus m plus 1. Look at this. This is our A square. This is. Now we have A square is equal to 4 times m square plus m plus 1. It is, this portion is always even. This portion is always even because it is a multiple of 2. I can write this 4 as 2 times 2m square plus m plus 1. whatever the value of this quantity is, m square plus n, I have two possibilities. Either this will give me a odd integer or even integer. Odd integer or even integer. Let me take the first possibility. It is 2 times 2. It is an odd integer overall plus 1. Even times odd integer. Even times odd integer is always even. Even times odd integer is always even. Even times odd integer is always even. Take any odd number. 3, 2, 3 the 6. Even 3, 4 the 12. Take 5, 4, 5 the 20. Take 7, 7, 4 the 20. It will give us always even. Even. This quantity is even and plus 1. If we add 1 into the even number, if we add 1 into the even integer, it will give us odd. It will give us odd. So, this quantity is odd whenever m square plus m is odd. M square plus m is odd. Second possibility is this 2 times this a square is equal to 4 m square plus m plus 1. Second possibility is this m square m is even. Even. Okay. 4 times even. 4 times any even number is even, because even multiplied with even always gives us even. It will become even. If add 1 into the even, it will become odd. It will become odd. So this or a square in both the cases, in that case, whether m square plus m is odd, m square plus m is odd, or m square plus m is even, in both cases it will give us an odd number. 4 times m square plus m plus 1 is odd. I have taken this first possibility where a is equal to m plus 1, it is odd number. Or we can describe 2m minus 1, taking 2m minus 1, it also gives us an odd integer. Let's see and find out how. Let me make some space. Okay. Now I have taking a equal to 2m minus 1, squaring both sides. We have a square 2m minus 1 whole square. Open this up, expand this. A square twice, first and second plus square of second. That's our 1. That's our 2 times 2m 1. 4m square negative 4m plus 1. Same fashion, taking 4 only common. M is also common, taking 4 only common. M square minus m plus 1. Again, I have two possibilities, whether it is odd or even. This m square minus m might be even or odd. I have two possibilities for this. Taking the first possibility, a square is equal to 4 m square minus m plus 1. Suppose it is odd. And second, 4 times a square is 4 times m square minus m plus 1. Now here m square minus m is even. Odd, 4 times any odd number will give us always even. If I take 3 here, 4 times 3 12, 5, 4 times 5, 4 times 7, 9 times 4, 11 times 4, they will all give me even number. Even times odd number are simply even multiplied by odd always gives us even. It's always even. And if we add 1 into the even, it gives us odd. So our a square, that is equal to 4m square minus 4m plus 1, where we have taken the possibility m square minus m is odd. It has given us this 4 times m square minus m plus 1 is odd. What about this possibility where this portion m square minus m is instead of odd even? Instead of odd, it is even. Now we are familiar. 4 is even. Even times even number. Even times even number. Even times even number always gives us even. Even times number. Even times an even number gives us even. and if you add 1 into the even, it will give us always odd. It will give us always odd. So we have proved the diligency of contrapositive. If a square is even, then a is even, then we have proved it's contrapositive. Contrapositive means if a is not even, if a is not even, then a square is also not even. Instead of even, not even, one can write odd. Instead of not even, one can write odd. And we have shown all the possibilities by taking both the results, both the possible formulae for odd number, that might be 2m minus 1, 2m plus 1, and after arriving here taking 4 common, m square minus m square minus m might be even, might be odd. We have discussed both possibilities. It's my tiny effort to show the application of contrapositive in the fascinating branch of mathematics that is known as discrete mathematics. It's all by itself. Next.